plus rho GH.
Okay.
And then it equals to P2 plus 1 over 2 rho V2 squared plus rho GH2.
Okay. So take a look at my equation on the videos. So you have P divided by rho G, right? And then plus V squared divided by 2G. And then should be have Z there. Okay. Equals to P divided by rho G, state number 2. And then V squared divided by 2G, state number 2. Plus another Z there. Okay. The first term is heat due to pressure. Okay. The second term is what? V squared divided by 2G. What is the second term?
1 over 2 rho V squared.
1 over 2 rho V squared. That is one form of Bernoulli. Okay, we have lots of Bernoulli equation form. I mean, my equation is what? Is based on P divided by rho G. So everything rho is actually being divided at the bottom. So that's why instead of rho G H, it become what? Only H, right? P divided by rho G. Okay, the one that you told us just now is actually one form of Bernoulli equation. Okay, the one that I put it there is actually when you divide it in with rho G. So that's why you have P divided by rho G, right? So the one that you told us just now for kinetic energy is half rho V squared. So I divide it into rho G as well. So become half V squared divided by G, correct? And then your plus should have, you told us just now is rho GH. So everything else divided with rho G become H only. Okay, but for state, am I clear?
Yes.
So that is another form of Bernoulli equation.
So biasanya question we are gonna use this form only ke macam mana?
It depends. It actually depends. The equation here is what? It's actually to prove P minus P infinity, right? And divide by...
Yes.
Yeah. So basically I need to re-modify my Bernoulli equation into that form. Right, Najmi? I can use yours. I mean the one that you perhaps you refer it on internet. I don't know. Okay, it's correct. It's correct. It's not wrong, but it's actually another form of Bernoulli equation. So what I did is actually everything else is divide by rho G. Okay. Am I answering your question, Najmi?
Yes, sir.
You asking me how I developed that equation, that Bernoulli equation, right? It's not like develop. It's just another form of Bernoulli equation. Okay. I told you just now there should be a Z there, right? So, but the thing is, we assume Z1 and Z2. I mean, the height difference between state number 1 and state number 2 is the same. It's actually the same the same line. Okay, we assume. Okay, so that's why Z1 and Z2 can be cancelled out. So that's why no, we don't have any Z there. Height difference. Okay. Anything else? So I should have 25 students here. So write down your names in the comment section under lecture series 2.3 superposition. Okay. But if you haven't completed yet, it's okay. No need to write down your name so I know who's not yet complete. So perhaps got some other problem or else. Okay. So if no question, I'm gonna give you one tutorial. Okay, tutorial one. Chapter 2, 7B, right? Right, so take a look at your GC. I just posted tutorial number 1. So do that now. Any question? I'm here.
Sir? No, sir.
Yes, no problem.
Sir, kalau question dia tahu dia pakai M, kita kena tukar M tak boleh pakai Q ke?
No. It is M as well.
Oh, okay. Thank you, sir.
Okay. So everyone done?
Belum, sir.
Okay. So I'll give you perhaps another 5 minutes. Okay. Okay, the first one, they ask you to draw the superposition. What kind of superposition is that?
Rank half body.
Rankine. Not accurate enough.
Rank half body.
Apa?
Rank half body.
Rankine half.
Body.
Anis, if you talk about rankine only, you have two types of rankine. Okay? So you have rankine half body, and then you have rankine when the source and sink is far away.
Sir, ulang balik tak dengar.
Okay. So if you talk about only
Sir.
rankine,
Sir, yang tadi saya cakap saya tak dengar.
okay. So if we talk about rankine, we have two types. Okay. Number one is rankine half body, and another one is when source and sink is there, but far apart. Okay. We call that as rankine oval. Okay. And then we have another rankine as well. Okay. But instead of rankine, okay, we call that as a flow past a circular cylinder. Okay. Still source and sink, but the position is correct enough to produce some sort like a cylinder. Okay. So yeah, so almost we have three of rankine. So if your answer is only rankine, there's no mark for it. So you need to put rankine half.
Okay.
Yeah. Clear, Anis, right?
Yeah.
Okay. Okay, next is to draw, right? Okay, show it to the camera. You're drawing. I want to see.
Yang saya draw ke sir? Yang saya draw.
Yes, everybody. Together with Anis as well. Semua sekali, semua orang.
Tunjuk kat kamera Tapi saya lukis yang overall, yang oval.
So,
Nampak ke?
okay, so meaning that one is wrong or correct, Anis?
Salah. Sebab ni oval.
Yeah. So now you know the difference, right?
Okay.
How about others? Tunjuk kat kamera. Mohon bertahan sikit dengan tangan dia. Penat sikit lah kan, tapi tak perlu. Nurul Huda, yes, correct. Huda is correct. Natasha, yes, correct. Wan Yusuf, yes, correct. Okay. Adiba, ya, so betul. Muhammad Syahmi bin Salim, yes. Okay. Alright, thank you everyone. Okay. So more or less you guys are able to draw rankine half body, but okay, some of you miss out on some important characteristic of the drawing. Okay, so perhaps if the mark is 4, for example, or 3, for example, so I'm going to give you 2. Okay. Some of you miss out on the axis, x and y axis. Okay, be careful on that. So you need to draw where is the position of x and y axis, as well as r and theta. Okay. Because without that, everything else at the bottom doesn't mean anything. We don't know where is your axis, where does the theta position or direction that you assume, either clockwise or counterclockwise. So normally we assume counterclockwise as positive. Right? It actually depends on you guys later when you work. Okay, you want to analyze this one. Let's say if your theta direction is you assume clockwise as positive, so meaning every equation is going to be flip. I mean reverse. Okay. But yeah, for what for normally what we do is the one that you learn in our lesson, which is x should be in x direction, y direction, and r and theta should be in counterclockwise for positive direction. Right. So remember that. Draw the axis, then you get the full mark. Clear? Yeah. Yes, it's no is only right. Yes, the origin is must be positioned at the source. Okay. For your answer at the bottom, which you answer, which we're gonna discuss later, everything is actually assumed at when the source is actually position of the axis. Okay. Right, clear for the drawing? So not only for these problems, everything else. Let's say if you analyze for superposition, for flow past a circular cylinder, or perhaps any other combination of basic elementary flows, okay, make sure you know where is your axis position. I mean, you need to draw the axis. Without that, there's no meaning. All right. Okay, next we go to question number 2. Question number 2 asking about velocity potential. Can you give me the answer? Anyone? Velocity potential. Anyone?
You are questioning SM to time. Like
Okay. You are cos theta
M to pi like
m divided by 2 pi
R.
ln r. Yes. Very good. Correct. So everybody got the same answer? You know what to do. Who's talking just now?
Abu-abu. Najmi Amrudin.
Okay. You got the same answer?
Najmi Amnuddin. Yes.
Right? So the method start with what? Determine the
Psi uni.
yeah. Use psi, right? The psi of the Rankine half body. Okay. So you
Yeah.
have QR sine theta
Yeah.
plus m divided by 2 pi theta, correct? Okay.
Yes, sir.
Yeah. So next, what you do? What you did?
Plus psi source.
plus the side of the source. Okay, so you get the side rank and half body.
Body.
So our question is actually velocity potential. Okay, it's actually phi, right? Make sure you able to differentiate the equation. Because based on my example is velocity field. Okay. So different. Velocity field is determine what? Speak up. I can see your how you talk. I mean, I can read your lips, but
VR and V theta.
yes, observe too. Velocity field is VR and V theta. Okay, be careful on that. Okay, my class previously, my class yesterday, some of them got it wrong. Okay. We want to determine velocity potential, which is phi. Okay. So yeah, what I did is actually I'm use VR. Okay. So VR equal to 1 over R del psi over del theta to determine VR. Okay, so after I found VR, I use the VR to determine phi, which is the equation is VR equals to del phi over del R. Can you see my presentation?
Yes, sir.
So in the end, you got your phi. It's actually U R cos theta plus M divided by 2 pi ln R. Right. So not to worry. I will share this one with you later. But now it's actually time for discussion. So done for B. Any question? Okay, next we go to C. They ask determine the expression of distance between B, between source and stagnation point as a function of M and U. Meaning B equals to some M and some U. Meaning expression. Okay. What is your answer? B equals to what? Anyone?
M over 2 pi U.
B equals to M over
2 pi U.
U. How about others? You all got the same?
Same, sir.
Okay, Mal the same.
I got the same answer.
Najmi also the same. Right, so you know how to determine that one, right? So B equals to M divided by 2 pi. Okay, just sharing to the class. Okay, again, they use stagnation point. I mean, they want to find B equals to M something, U something at stagnation point. So meaning there is a position there. So it can be what? It's not going to be always stagnation point. Perhaps at any position. Okay, for example, at theta 30 degree and R equals to A, for example. So what you got to do is just replace the equation with the one that been given. But for our case here is actually stagnation point. So yeah, open up your mind. Okay, it can be any position. So B can be equal to something at any position, right? So now for this case, it's B equals to M divided by 2 pi. Very good. All right. So the last one is determine psi at stagnation point, meaning not the value, the expression. Okay. Always find the expression first. Okay. Later we put the value. Okay. What is your psi? Any? Your answer. Anyone? I can see you are some of you mousing the answer. I mean menyebut-nyebut jawapan tu, tapi malu nak buka kamera. Sorry, speaker.
Pi BU sir. Psi equal to pi BU.
Psi equals to pi BU. Alright. Semua yang lain dapat? Okay. So the answer is psi equals to pi BU. So done. Any question? Any question at all regarding this tutorial? Okay. So if no, hopefully you all understand how basically we deal with superposition. We always play around with the differentiation or integration, and we put the location, which is for our case here is theta, right? And then perhaps the direction, r equals to a or r equals to b, something like that. Okay. So I give me a second to set it up. Okay, so you can see the answer now in the C. Okay, so I got a few more questions, tutorials, but the thing is, we're gonna hold it now. At the moment, right? Because we're gonna continue with chapter number 3 for next class. Okay, but a week before your ODL exam 1, because your ODL exam 1 is chapter 1 and chapter 2. Okay, so a week before ODL exam 1, so we're gonna have the whole week tutorial session for chapter 1 and chapter 2. Is it okay for you? My plan?
Okay.
Okay?
Okay, sir. Okay.
Right. So for next class, chapter 3. So a week before, we're gonna go back to chapter 1 and chapter 2 for some kind of tutorials to prepare yourself with ODL exam 1. So wait, I'm gonna give you attendance. V dot over L. Okay, M and Q is actually the same. Okay. It can be and it can be anything actually. But Q is the one that represent the actual Q, because the small q is actually from the large Q, right? Capital Q. It's actually from Q equals to AV. Remember my derivation? Okay. When you deal with source, we draw the expansion of it and the A, right? The change of area. So when capital Q is actually equals to AV. So we want to derive for V, right? So for our case, that one is actually VR. So we replace those V from the original equation with VR and A with dA. So instead of using capital Q, we use small q to represent the change of it. Okay. We cannot use we still can use capital Q, but how we want to differentiate. So that's why we use smaller q, right? And M is just a representation of Q, but the same. Perhaps, in fact, it can be anything. Okay, it can be, I don't know, V dot, for example. It can be S. Depends. But the thing is, by looking at the expression of psi based on our previous tutorial here, you know that those M is actually Q, right? Because other is actually the same. So meaning the M is actually Q. So by right, if they change it into V dot, it's not really a problem for you as well, correct? Because others is actually the same. Am I answering your question? Yeah, it's actually all the same. So when you answer just now, yeah, when you answer just now, I can't remember who's asked us just now. Is it Ajmi or Nafal? Do I need to use M or do I need to use Q? It actually depends on the expression given in the final exam. So let's say they use V dot. You need to use V dot. You cannot use Q. Yeah, I know you already found the answer. It's correct, but it's not follows the question. Right? So be careful on that. Anything else? All right. Fill up your attendance. So on chapter 3, so we're going to discuss on flow pass immerse bodies. Okay. So basically we're going to play around with the aerodynamics, okay, but more on the frictional effect on the surface of any surface. So you're going to have what? Coefficient of drag, coefficient of friction, lift, right? And It's 10 hours. Surface roughness and all new. Everything regarding the skin friction on the surface. Next slide. Your ODL exam 1, perhaps, okay, perhaps not yet finalized, but maybe 1 week after Hari Raya. Okay, so be prepared. So Raya dulu dengan seronok-seronok, and after that your exam. So 1 week before Raya tu, we're gonna have our tutorial session. Okay, 23 students. I'm still waiting at the 2 students fill up their attendance. Who else? Not yet. Okay. So I think that's all for today. So hopefully this session is beneficial to you all. So we end our class with tasbih kifarah and salawat. Okay, thank you and assalamualaikum warahmatullahi wabarakatuh.
Bisa.
Waalaikumsalam warahmatullahi
Salam, thank you, sir.
Thank you, sir.
wabarakatuh.
Thank you, sir.
Thank you, sir.